Welcome back. Today we're going to be talking about infrastructure threats and security monitoring. This is Module 8 or Chapter 8 in our textbook, and this is our CompTIA Security Plus Guide to Network Security. Remember, this is going to prepare you to take the CompTIA Security Plus exam if you decide you want to do that, which is optional. So we'll proceed. By the end of this module, you should be able to describe the different types of attacks on networks, explain how to perform security monitoring and alerting, list and describe different email defenses. Okay, so we'll start off with what's called an on-path attack. An on-path attack occurs when a threat actor positions themselves in the middle between two communicating users or devices. So the following are advantages of an on-path attack. It can occur without the two targets knowing that an attacker is present. It gives the attacker flexibility because they can either eavesdrop to gather valuable information or they can modify the message before sending it on to the recipient. And this is called a man-in-the-middle attack. This is where a threat actor is positioned in a communication between two parties. The goal of a man-in-the-middle attack is to eavesdrop on the conversation or impersonate one of the parties. A typical man-in-the-middle attack has the following two phases. The first phase is intercepting the traffic, and the second phase is to decrypt the transmissions. So you have Bob here that says, send me your public key to Alice, and then send me your public key. So Alice responds, my public key is ABCD, but you can see here where Eve is intercepting that and sending Bob Eve's public key, which is WXYZ. Bob sends what he thinks is Alice, but he's actually sending it to Eve. Says my account number is 1234, and Eve sends to Alice, my account number is 6789. So you can see where now Eve is changing or intercepting the conversation between Bob and Alice. A replay attack makes a copy of a legitimate transmission before sending it on to the recipient. The attacker uses a copy at a later time. The session replay attack involves intercepting and then using a session ID to impersonate a user. Remember, session IDs are generally generated on a website. Once you visit the web page will generate that session ID. Kind of like if you go to a local fair and they stamp your hand, or if you go to a movie, they tear up your movie ticket. That's your session ID. That's a proof that you've already come in, that you've been authenticated. So threat actors use several techniques for stealing an active session ID. You have network attacks, you have endpoint attacks, and you can see all the different types as they're listed here. The man in the browser attacks and intercepts communication between parties to steal or manipulate the data. It might be between a browser and an underlying computer. And a man in a browser attack usually begins with a Trojan infecting the computer and installing the extension onto the browser configuration. When the browser is launched, the extension is activated and waits for a specific web page in which a user enters information such as an account number and a password or a financial institution. When the user clicks submit, the extension captures all that data from the fields on the form. Okay. This is where we talk about domain name system, or DNS. That's the hierarchical name system matching a computer names and its IP addresses. It's what translates www.wherever.com into an IP address like 123.45.67.89. So a DNS-based attack substitutes a DNS address so the computer is silently redirected to a different device. Successful DNS attacks have two consequences. One is URL redirection and domain reputation. I don't know if you remember, about 6 or 7 years ago, Yahoo, the search engine company, was under a DNS attack, and someone forged an authentication record that basically changed Yahoo's webpage to point to another server or an unknown server. So when somebody went to www.yahoo.com, it redirected not to Yahoo's web server, but to a unknown server, and basically took down the Yahoo website. So be careful. Like if you're responsible for a company or a business, and you have to make sure that the website is secure, that you want to make sure that it doesn't fall into a DNS attack. Okay, you can see where the attacks using DNS include DNS poisoning, that's one of them incident, and DNS hijacking. DNS poisoning modifies the local host file on a device to point to a different domain. Threat actors will add a single entry that directs the computer to a DNS server that's under the control of the attackers. DNS hijacking is intended to infect an external DNS server with an IP address that points to a malicious site. The DNS hijacking has the advantage of redirecting all users accessing that server. Attackers attempting to exploit a protocol flaw and convince the authentic DNS server to accept the fraudulent DNS entries sent from the attacker's DNS. So here's an example. The attacker says, what is the address of www.evil.net? And the valid DNS server says, please send the IP address of www.evil.net. And it says, here are all the evil addresses. Okay, then you have a good user that says, I want to know the address of www.good.net, and you can see what it does is it pulls from that valid DNS server the attacker's address. So the next type of disruption is called a denial of service, or DOS attack. It's a deliberate attempt to prevent authorized users from accessing a system by overwhelming it with requests. One of the best ways to describe this is just imagine you're at, say a checkout lane for a grocery store. And in front of you, and you only have like maybe a carton of milk or something like that, one thing. And you want to go ahead and pay it and check out and go about your business. Well, in front of you are 10 people, each with nothing in their hands, but all they're going to do is they're going to walk up to the grocer, to the person at the checkout, and they're going to say, hi, how are you? My name is, it's good to see you today, and I just wanted to say hello, and I'm not buying anything, but I just wanted to say this to you. They take up a minute of their time. The next person comes up, says, hi, how are you? It's good to see you. I, wanted to stop by and say hello, and saying that maybe the same thing again takes up another minute. So you get where this is going. By the time the 10th person comes through, you've wasted 10 minutes. So that person who wanted to buy a carton of milk is getting very frustrated. They've been denied the service of the checkout person. Now, if you use a distributed denial service, which uses hundreds and thousands of devices flooding the server with requests, remember the server has to legitimately answer each request, even if it's a good or bad request. Then if in your protocol, in your network protocol, the request has to time out on its own. It's not up to the server to say, oh, this looks bad, I'm not going to do this. It has to answer each one. So if I have 10 of them doing those, just like that DOS attack, 10 of those, that's 100 of those, okay? Or it can be thousands of those. They're flooding the server with requests. And it then becomes like standing in front of a fire hydrant trying to get a cup of water, or standing under Niagara Falls. So the devices participating in the DDoS attack are infected and controlled by threat actors so that the users are completely unaware that their endpoints are part of a DDoS attack. There are two means by which attackers can generate data to overwhelm the system. Use large numbers of compromised devices, each sending a bogus request. Again, standing up there and not buying anything and just, wasting time. Or the use of what's called an amplified attack or reflection attack, where the threat actors use a misconfigured internet device or service in such a way that causes the device or service to reflect and generate an even larger payload at the ultimate target. Okay, some networks attacks come from malicious software code and scripts. Now, there's a software that Microsoft has, it's called PowerShell. It's a task automation and configuration management framework from Microsoft. The administrative tasks are performed by commandlets, which are specialized .NET classes that implement a specific operation. PowerShell allows the attackers to inject code from a PowerShell environment into other processes without first storing any malicious code on the hard disk. You have also Visual Basic for Applications, or otherwise known as VBA. It's an event-driven Microsoft programming language. VBA allows developers and users to automate processes that normally would take multiple steps or levels of steps. As a side note, a long time ago, Microsoft wrote VBA as used for its macros in its products like Word, Excel, PowerPoint, and so forth. And what it does is allows you to have, the macro for like your word processor. You type hello, and it'll type out. If you program it right, it'll type out an entire paragraph. So you can see that here, this third part, which is used to automate a complex task or repeating a series of tasks. A macro is something small that does something big. Python, if you remember your programming language, Python is a programming language that can run on several operating system platforms. Best practices follow when using Python to include the following: using the latest version of Python, staying current with vulnerabilities with Python, and be careful when formatting strings in Python. And download only vetted Python libraries. Bash is the command language preferred or interpreter for the Unix operating system. And bash scripting is using bash to create the script. The exploits have taken advantage of vulnerabilities in bash. For example, one vulnerability allowed attackers to remotely attach a malicious executable file to a variable that is then executed when bash is invoked. Okay. So this next topic talks about the OSI model, which is your relates to the internet connections, your networking connections. So the top layer is your application layer. Remember, down the bottom layer is your physical layer. Layer 2 is your data layer. So layer 2 attacks are what we're going to be talking about here. That's basically the data link layer. So it's responsible for dividing the data into different packets. So a compromise at the layer 2 can affect the entire communication. Why? Because it's just like something messing up what's going on at the post office, and all the letters in there are getting misrouted. Okay, it's disrupting the communications. So for instance, here's a good example of the TCP/IP or the TCP/IP stack. The top layer is the application layer. Down below is your physical layer, and you can see the data link layer, and that's where the initial compromise is, from the sender to the receiver. So you have your address routing protocol, poisoning, otherwise known as ARP. If the IP address for a device is known but the MAC address is not, the sending computer then sends an address resolution protocol packet to determine the MAC address. The MAC addresses are stored in an ARP cache for future reference. ARP poisoning then relies upon MAC spoofing, which basically is imitating another computer by means of changing the MAC address. Two common attacks involving spoofing MAC addresses are cloning and MAC flooding. In a MAC cloning attack, threat actors discover a valid MAC address of a device connected to a switch and spoof that MAC address on their own device, and the switch has changed its MAC address table to reflect the MAC address with the port to which the attacker's device is now connected. In a MAC flooding attack, the threat actor overflows the switch with Ethernet packets that have been spoofed so that every packet contains a different source MAC address. So here's a credential relay attack. Bob is tricked into attempting to sign into Eve's computer. Eve captures Bob's authentication digest, and Eve uses Bob's digest to then sign into the server. So Eve has captured Bob's information and is impersonating him. A credential relay attack attempts to steal authentication credentials and then use them to access a system. The attackers intercept digests of user passwords as they're being transmitted and then relays the client credentials to impersonate the user. Okay, here's our knowledge check activity for Chapter 8, Number 1. UA has discovered that the network switch is broadcasting all packets to all devices. She suspects this is a result of an attack that has overflowed the switch MAC address table. Which type of attack would she report? Is it spoofing, cloning, flooding, or overflow? Now go back and look at the statement. She suspects that it's the result of an attack that has overflowed the switch MAC address table. Which type of attack would she report? It's broadcasting all packets to all devices. Take a minute, think about it. So it's a MAC flooding attack. You would have thought it might have been a MAC overflowing attack, but it's the flooding attack. Remember, flooding is just like if the sink overflows, it's flooding onto the floor, or if a tub breaks and the water flows onto the floor, it's flooding onto the floor. It's a flooding attack. The threat actor will then overflow the switch with Ethernet packets that have been spoofed so that the switch enters into what's called a failure mode, which is a predefined set of actions based on a failure of the network component. Okay, so there are some monitoring methodologies that we can use. Monitoring involves examining the network traffic activity, transactions, or behavior to detect security-related anomalies. Anomaly monitoring is designed for detection statistical anomalies. A secure baseline for normal activities is compiled so if there's a deviation from that baseline, an alarm is raised. So it's looking for anything that's out of place. Signature-based monitoring examines network traffic activity, transactions, or behavior to look for well-known patterns to compare these activities against a predefined signature. Okay, that's important. They're different here. Anomaly versus signature. Behavior-based monitoring uses the normal processes and actions as the standard. It continuously analyzes the behavior of processes and programs on a system and alerts the user if it detects any abnormal actions. The heuristic monitoring is founded on experience-based techniques and attempts to answer the question, will this do something harmful if it is allowed to execute? It's like thinking ahead and asking the what if question. So here are your different activities. You have scanning, reporting, quarantine, alerting, alert tuning, and archiving. Almost sounds like an antivirus. What are you going to do when you find this virus? You're going to quarantine it, you're going to alert, maybe you're going to delete it or whatever. But that's different than what we're doing here. Some tools for monitoring and alerting. So what they're doing is they're collecting and analyzing the data packets that cross a network. They can provide valuable information. The first is Wireshark, which is it's a popular GUI packet to capture and analysis tool. TCP dump, it's a command line packet analyzer. TCP replay, it's a tool for editing packets and then replaying the packets back onto the network to observe their behavior. There's also flow analysis. It's a network traffic analysis, the process of monitoring the network's devices and sounding an alert if it exceeds that baseline. Flow analysis for information security is different from traditional network traffic flow for several reasons. One, it eliminates monitoring agents. Two, it uses deep packet inspection. And three, it provides a richer information. NetFlow is a session sampling protocol that collects IP network traffic. So here's an example of network traffic analysis output. Okay, so you can see the graphic symbol and the bar graphs and the pie and the graphic graphs. Here's a network analysis output. And the next thing is you want to make sure to keep your network secure so that you don't have the data loss. And that's where data loss prevention comes in, because it's a system of security tools used to recognize and identify data that's critical to the organization and assure that it's protected. Most data loss prevention systems use content inspection, which is a security analysis of the transaction within its approved context. The administrators create DLP rules, which are uploaded to a DLP server. If a policy violation is detected by a DLP agent, it's reported back to the DLP server. So the next is a simple network management protocol, or SNMP. It's a protocol used to remotely monitor, manage, and configure devices on a network. You have what's called an SNMP trap. It's a type of PDU that sends an unsolicited message to the manager about critical events in the managed device. Log aggregation enables security personnel to gather events from disparate sources into a single entity so they can be searched and then analyzed. The security content automation protocols, or SCAP, can help automate vulnerability management and determine whether the enterprise is compliant with required policies. A security and information and event management product consolidates real-time security monitoring, management of security information with analysis and reporting of security events. It has the following features: aggregation, correlation, automated alerting and triggers, time synchronization, event duplication and logs. Here's an example of an SIEM dashboard. You could see the different things that it's monitoring and how it's taking the data and representing it. So you have security, orchestration, automation, and response. That product is similar to an SIEM, and that is designed to help security teams manage and respond to a high number of security warnings and alarms. It takes a step further by combining more comprehensive data gathering and analytics in order to automate incident responses. So let's look at our next check activity here. Which type of monitoring methodology looks for statistical deviations from a baseline? Statistical deviations from a baseline. Is it A, B, C, or D? Well, if you were to become familiar with each of these, you'd find out it's your anomaly monitoring, number C. Anomaly monitoring is designed for detecting statistical anomalies. First, a secure baseline of normal activities is compiled over a time or baseline as a reference instead of data against which operational data then is compared. Whenever there's a significant deviation from this baseline, an alarm is raised. So now we get to talk about email. Email monitoring and security. The basic components involved in sending and receiving emails are what are called a mail user agent, or MUA, and a mail transfer agent, MTA. The MUA is what's used to read and send mail from an endpoint. So it's like your Thunderbird, Outlook, Outlook Express, or whatever you have that actually displays and allows you to compose messages. It's also, if you're using things like Gmail, it's that window or that interface that allows you to compose messages and read your messages. The MTA, those are programs behind the scenes that accept email messages from the senders and route them toward their recipients. So when you compose a message, whether it's on Gmail or whatever, that gets handed off to that MTA. And then that MTA is what actually delivers it. So as an email is transferred from the MTA to MTA, from like say Gmail to Yahoo, the information is added to the email header. The email headers also contain an analysis of the email by that MTA. Okay, so there are threats to email. You have malicious payloads, embedded links, impersonations, forwarding. Later on, when we get into the phishing attempts, you in depth on those, you'll understand more about what it means to when somebody puts like a tracker link in an email, or if the email looks like it's impersonating something else, another legitimate website. So there's some email defenses. You have your spam and phishing filters can be help address phishing attacks and anti-malware by having what's called a sender policy framework, domain key identified mail, domain-based message authentication, reporting and conformance, otherwise known as DMARC, and secure email gateways. The sender policy framework is an email authentication method that identifies the MTA, or mail transport agent, email servers that have been authorized to send an email for a domain. So you don't want to be having Yahoo send an email message from Gmail to somebody at AOL.com. That's where your sender policy framework, or your SPF record, helps to protect a domain from spoofing, and also helps prevent messages from a valid domain from being marked as unwanted spam. Your DKIM, or your domain key identification mail, is an authentication technique that validates the content of that email message. The validation is accepted through a digital signature. Here's a Cengage SPF record. So if you look at it, it's hard to read on the screen, but you can see the information there. So your domain-based message authentication, reporting, and conformance, or DMARC, allows the administrative owner of a domain name to publish a policy on their DNS records to specify which mechanism, DKIM, SPF, or both, is used when sending mail from that domain. Secure Email Gateway acts as a proxy for that organization's email server. And that SEG can filter and inspect emails from malicious content. Some limitations of SEG include single-layer security, exposing protections, and multiple root domains. Okay, here's knowledge check activity number 3. Which of the following email defenses uses a digital signature? Using a digital signature. Is it SPC, DKIM, DMARC, or it depends? So it's DKIM, Domain Key Identified Mail. It's an authentication technique that validates the content of the email message itself. This validation is accomplished through a digital signature. That's important. So whenever you hear digital signature, it's DKIM. Start making that association. Okay, we are reaching the end of the chapter here. So you want to rate your competence in the following module objectives on a scale of 1 to 5, whether 5 indicates you have full confidence in your competence of that objective, and 1 indicates you have very little confidence in your competence of that objective. If you self-score less than 4, you should consider reviewing the module and related exercises. Remember, you want to be able to describe the different types of attacks on networks, explain how to perform security monitoring and alerting, and list and describe different email defenses. That's all part of this module. Okay. All right. This is the end of the chapter. We'll see you in the next chapter. Have a nice day.